Hey guys, this is Tomek. In this video I want to show you how you can deploy stateful application into your Kubernetes cluster and what you have to remember about. So let me first show you the application itself. I developed something very simple, that's the bucket list, where you can add the items to your bucket list, right? And the items are stored in the local file system, actually in one of the files. I will show you the source code in a second. So as you can see, when you visit the page again, the items are stored. You can still add the new ones. There are two versions. That's the first one, and the second version is the same application but with CSS style, so it's a little bit nicer from the graphic point of view, right? Alright, so that's the application itself. Let's review the code. I released this simple application as an open source and it's available on the Docker Hub for the container image. There are two versions, 0.1 which is a simple HTML page, and 0.2 with CSS styles, so with nicer looks. And source code is also available on the GitHub. All the links you will find in the description of the video. There's Cat8s folder with all the YAML definitions. That's what we are going to do today, so you can review that later. Static with CSS style, Docker file to build an image, and hello.py with the source code. Let's review the source code since this is just 40 lines of code. This is a simple Flask application. By default, it will call a function called printDream. printDream will create the HTML page together with the form to add the dream, and also read the existing items from the app-storage/list.txt file. If the file doesn't exist, it will print the message the list is empty. There's also a function to add the dream, which will open the file with the append mode and add whatever you send via form to the file. So that's pretty much it. In the background, I was already creating the cluster. As you can see, the Kubernetes cluster just finished deployment. And let's review the nodes, just to make sure we do have an access to it. There are 3 nodes. Perfect. Let's clear the screen and start. Alright, so let me create the directory B where I will store all the YAML files for today. And let's start with generating the first YAML file. I will create a deployment bucket list using the image on.tom bucket list in version 0.1. I will use the dry run option, so it will actually not create the deployment either with -o YAML print the YAML definition. That's perfect. So let's redirect the output to the file called deployment.yaml. So just to be clear, this command didn't create any object in the Kubernetes cluster. It just created the YAML definition for us, which we saved to the file. So now we do have a file, so we can use more of a declarative approach to apply the changes. If you're not sure what's the difference between the imperative and declarative approach, I created another video about that. You can find the link somewhere in the description, I suppose. So let's apply the changes. The deployment was created. So right now we can review our objects with kubectl get all. As you can see, there is a deployment and bucket pod is being created right now. So in the meantime, we can start with creating the service. For that, I will go with kubectl expose deployment. So we will get the IP address on which our customers can access our application. Type load balancer, specified port and target port. In both cases, this is port 80 for this application. Dry run again, just to get the result on the screen. And specify the output to YAML, so we will get it in the YAML format. The other one is, for example, JSON. Alright, so we do have the output on the screen, so let's do the same to redirect that to the file. Obviously, I could have redirected to the file in the first place, but I just want to show you what's the output of the command. Alright, so our service definition is also ready. So let's reapply the changes again. With kubectl apply -f, so there's a file specified, and let's specify the whole folder, and the service is also created. If we check again the resources with kubectl get all, we should see the service is created, and it is. the IP address or external IP is still in the pending state. So let's give it the minute before that's fully ready for us to visit the page. Alright, I took a short break, so around a minute or two later, let's check it out again. The same command, kubectl get all, and I'm expecting to see the external IP address for my service, and there it is. Let's try to visit it, and voila, that's our deployed application with the external IP address. So I can add some of my dreams, for example, visit California, move to Spain, what else? Maybe learn Spanish since I'm moving to Spain, right? Alright, so that's about it. Even if we refresh the page or access it from the other location, the state is saved because that's the stateful application. Okay. What will happen with our application when the pod will fail for some reason? So let me split the screen. On the top of the screen I will execute watch every second the command kubectl get pods, so we can observe the situation on our cluster. And on the bottom part of the screen I will simulate the failure of the pod, so pretty much just kill it. So let me do it. Kubectl delete pod and the pod name. Since we do have the deployment set, the new pod should be created almost instantly once the old one is broken, and that's what happened, right? You can see that the fresh pod is running. Let's review our application. If we visit the page again, the list is empty, so we lost our data because it was stored locally in our pod. So we can recreate the data, for example, visit California, move to Spain, etc. And yeah, as long as pod is running, we've got our data, right? But what if we are trying to do something else? For example, we developed a new version of the application, or the new version is available, and we want to update our deployment. So let me do it right now. I will go to the deployment.yaml, find the image line, and update the version from 0.1 to 0.2 with the nice graphic interface. Autosave is enabled, so all I have to do is to go back to my terminal and apply the changes. So kubectl apply -f and specify the folder, and look at the top of the screen. There is a rolling update going on. So first the container or the pod with the new version is started, and once this is started, the old one is being terminated. So once again, if we go to our application, we've got a new look. However, the list is empty again. So we lost the data again due to the upgrade. So this approach is definitely not good for the stateful application. Let me close the additional window and let's clear the screen a little bit to have a fresh start. And I will navigate to the Kubernetes documentation to find a solution how we can use external storage to store our data, which will be independent of the pod lifecycle. There is a concept called persistent volume and persistent volume claim to be able to use the external storage in our pod, which will be mounted to specific location. So let's go to tasks, configure pod and containers, and find the section configure pod to use a persistent volume for storage. It's a very nice document. You can go step by step, but I will just browse through it. First, you can create a persistent volume. That's the type of storage you want to have. That might be, for example, NFS share. Then you create a persistent volume claim, which have a name and access mode. It's quite important to understand the access mode. There are only 3 of them, so it's not that difficult. And once this is done, you can create a pod or update existing pod with a volume specification where you specify what volume is mounted, or no, what volume is going to be used based on the claim name in this case. And later on the container specification, you specify the name of the volume and the mount path of this volume. So in this example, that's for the Nginx HTML page. It's not useful for us, but we can use that as an example. there is something else we can do. Since we are using Google Cloud and Google Kubernetes engine, there's a way to automatically provision persistent volume for us. So once again, I'm navigating to the Google Cloud documentation, look for the persistent volume, and there should be a nice article about that. Yeah, the first result, persistent volumes with persistent disks. And let me scroll down a little bit. On the right hand side you can see there is a section dynamically provision persistent volumes, and that's perfect. So let me copy the YAML example. Alright, once copied, I will navigate back to the Cloud Shell. Let me open the editor and create a new file called pvc.yaml. Obviously the file name doesn't matter, but it's good to use something meaningful. PVC stands for persistent volume claim. So let me change the size of storage to 1 GB because that's more than enough, and change the name for something more meaningful for me, for example bucket list storage. So that's pretty much it. Our persistent volume claim definition is ready and auto-saved. So let's provision that. Once again, to do that, I will just apply the changes on my folder or directory, kubectl apply -f for the B folder, and as you can see the persistent volume claim has been created. When we go with the command kubectl get all, we will actually not see that. Even though the command says get all, it doesn't show all the resources. So to get the PVC, we can go with kubectl PVC. We can see that persistent volume claim has been bound. So the persistent volume also exists. It has a name and it has a size. And actually, to show you what that is, let me navigate to the Google Cloud Platform to Compute Engine section and disks. And as you can see, the first item is the persistent volume, which was created for our persistent volume claim. I know that might sound a little bit complicated at the beginning, but you can browse through the document I presented, and I will put the link in the description to be more familiar with that. So once our persistent volume claim is created, we can start using that in our deployment. Now, where to put it? This section is just for the deployment, and the template section is for our pod. So that's the specification, this section over here for the pod. So right now we can specify which volumes will be used. In our case, that will be just one volume. And once this is done, in the container specification, we can specify the volume mount. So let's go for the pod specification to specify volume, or volumes actually to be exact because of the plural. The first volume will be named, let's call it bucket list storage. Now we have to specify what type of volume that is, and in my case this is a persistent volume claim. Capital and small letters are important over here, and let's specify the claim name. And the claim name is in our PVC, which is, well, also bucket list storage. So let's use the same claim name. So the volume specification is completed. Now for the container specification, we have to add the volume mount. So new line with the volume mount, and there is only one volume mount. Let's give it, let's say where it will be mounted. So mount path up storage. That's the one we used in our application in the source code, if you remember from the beginning of this video. And the name of the volume mount, let's use the same name that was created for our volumes section. So it will know which volume to mount. This mount path up storage, if I navigate back to my source code of the application, you can see that's the location where our bucket list is stored. That's why we want our pod to use this location mounted to the external storage, right? Alright, the file is auto-saved, so we are good to go with the with applying to deployment. Let me share the screen again. On the top you can see kubectl get pods. The pod is running. Let's apply the change. The pod will be recreated because we changed the definition of the pod, right? We changed the specification of the pod, so the new pod has to be created. Once this is done, the old pod will be terminated. So this is a rolling update. Once again, even though we haven't changed the version of the image, it's still a rolling update because we changed the specification of the pod. So if we refresh the page, the list is empty again, but that's okay because right now we are using the new storage. So I want to be able to save my dreams, right? I want to be able to visit California, and I don't know, I want to be able to learn how to pilot a plane. I'm not even sure if that's the correct English, doesn't matter. And go to Spain, right? That was one of my dreams. And yeah, I think that's about it. That's enough. So let's do the test again. Let's see what will happen right now if we will delete the pod. So let's go with kubectl delete pod, specify the pod name. Since I do have a deployment, once the pod is terminated, a new one is created almost instantly. So right now I do have a new pod created, and let's refresh the page again. And hopefully our list is saved, and it is, because it is right now stored in the external storage, and each pod deployed with the specification we will use this exact same endpoint for the storage. So another thing is to keep up with those videos, for example, so we can still add items to this list. Okay, so that works, but what about the updates of the application, or even scaling up the application? Now that gets a little bit more complicated. First of all, the application I've written isn't optimized for scaling it up, and secondly, issue is with the access mode of our external storage. As you know, Kubernetes cluster might have more than one node. In our example there are 3, so having 2 pods, they can be deployed on 2 different nodes. And when we navigate back to the documentation page, the access mode we have used is read write once, and when we check the definition, this access mode can be only mounted as read-write by a single node. So if we've got 2 or more pods and they're running on different nodes, it will be impossible to use the same volume. The solution might be read-write many access mode, but that's not supported by the compute engine persistent disk. So when you think about it, that introduces the issue even with the rolling update, since the rolling update would first create a new pod with applied changes, and once the pod is up and running, it would terminate the old one. If the new pod will be scheduled on different node, it will never successfully mount the volume. So we can describe our deployment to check the strategy type, and the default one for me is the rolling update. So the solution is, we've got at least 2 options. One is to make sure that the new pods will always be scheduled on the same node, and for that we can search for the node affinity, and I think there should be a nice result in the Kubernetes documentation. Assign pods to nodes using node affinity, so that will be one of the solution. And the other one, which I'm going to use, is to change the strategy type for the update from the rolling update, which is default, to the strategy called recreate. So in this case, even if the node fails, the pod will be scheduled on a different node, and that will work perfectly fine. So once the strategy type is changed, let me apply the changes. In this case, the pod is not recreated because I haven't changed anything in the pod definition. However, when I check the deployment definition, I'm expecting to see, yes, the strategy type changed to recreate. So let's try to do the update. At the top of the screen, you can see running pods. Let me clear the screen, and I will update from version 0.2 back to version 0.1. And once the changes are saved, the file is auto-saved, let me execute kubectl apply, and what you can notice, first the old pod is being terminated, and once this is stopped, a new pod will be created. And even if the pod is created on the new node, we do not care, because at the moment of the pod creation, no one else is using the volume, so that will work. However, it does introduce the downtime of the application during the updates because no pod is saving data. Okay, our new pod is up and running, so let's visit the page, refresh the page, and we've got ugly version 0.1, but all our bucket list items are saved. So that covers the stateful application with just one replica and some of the update strategies. What about the scaling of the application? For that, you can check out the statefulsets. It's a little bit out of scope of this video, but I will also put the link in the description of this video if you are more interested in this topic, or check out my channel. Probably I will create some videos about that in the future. But right now let me delete the environment. So first let's delete our Kubernetes resources, and then I will go ahead and also delete the cluster. So I will not be charged for the cluster when I'm not using that. Once the deletion is completed, it's worth of checking if the compute engine disk was also deleted. It should be, but better safe than sorry. Alright, that's it for today. Thank you for watching and have a great day.